Hello, welcome to the video on simplifying radicals. This is our second example set B. So hopefully you had a chance to apply what we learned in the lesson in example set A. And what we're going to do here is just continue to practice. And I'm trying to throw in a little bit more variety of problems so we can assure that you understand the principles that we talked about in the lesson. Let's go and take a look at our first problem. So recall, what we want to do is look for perfect squares for those radical expressions. Look for perfect square factors. Okay, so factors of 28, the number we need to simplify, are 4 and 7. Okay, that's one pair of factors, but we want that set of factors because we have a perfect square, and that's 4. So let's rewrite this expression like this: 3 times 4 times 7. Okay, so instead of 28, we're going to write this as 4 times 7, and that's nice because we can use one of those properties and write two individual radicals now. So this is going to be 3 times the square root of 4 times the square root of 7, and now I can get out that perfect square and take the square root of that particular number. So this is going to be 3 times 2 times the square root of 7, or 6 times the square root of 7. Okay? So not too difficult, but just take your time, step by step, and if you identify a perfect square factor, then you should be well on your way. Okay, it's not too complicated. All right, let's go down and take a look at our next problem. So I look at 2 radical 5 over radical 3. Okay, now the numbers underneath the radicals don't have any perfect squares in them. So all we have to do here is just rewrite this without a radical in the denominator. Remember, we're not allowed to have a radical in the denominator, so we have to rationalize. So we have 2 radical 5 over radical 3, and the way we rationalize is to multiply the numerator and denominator by whatever's in the denominator. Okay, so we have a radical 3 here, so I'm going to multiply it by a radical 3, but because I'm multiplying denominator by radical 3, I also have to apply multiply the numerator by radical 3. And when we do this, anytime you multiply a radical by itself, the radical goes away, so it's simply 3. And now we're left with 2 times radical, let's write it this way, 2 times radical 5 times radical 3. Okay, and that's going to be 2 times, here we just simply multiply these numbers, the square root of 15 over 3. And there you go. All right. Okay, so moving on. So what do you think we want to do here? All right, we could definitely take the square root of 4 in the denominator, but I'm going to show you something even easier. Okay, let's go ahead and use one of our properties, but we haven't used it this way. Instead of having 2 separate radicals, one for the numerator and denominator, I'm going to write this as negative 1/3 times the square root of 20 divided by 4. Okay, and what's 20 divided by 4? Well, it's 5. So this is the same thing as negative 1/3 times the square root of 5, and I'm done. Okay, you could have also done this, negative 1/3 times the square root of 20 over the square root of 4 here is 2. Then you would have had negative 20 over 6, and then what you have to do here with this negative 20, there's a 4 times 5 is a perfect square, and you have to take that perfect square out. But you can see here, in my opinion, the way I approach the problem is a much simpler, cleaner way. But bottom line here is just recognize that the properties can be applied in reverse. Okay, so instead of having a situation like this, 4 over 7, where you split into 2 separate radicals, you can also take 2 separate radicals and put them under one big radical. So it all depends on what's most advantageous. Okay. All right. And matter of fact, that's also a little bit of a matter of opinion, but whatever works for you. All right. Negative square root of 700. Now this might be daunting, but hopefully we're looking for a perfect square. You recognize that 7 times 100 is a nice perfect square. Okay, so let's write this as negative square root of 100 times 7. So now I'm going to have, you just have to be careful with this negative sign. It's going to be negative square root of 100 times the square root of 7. So this is going to be negative 10 times the square root of 7. All right? Just be careful with these negative signs that you don't lose them along the way when you're working. Okay, so let's finish up with this particular problem. Here I'm squaring this radical expression, so I'm going to be multiplying 2 times the square root of 5 over the square root of 6 by itself. So let's go ahead and do that. 2 times the square root of 5 over the square root of 6. Okay, that's the same thing as this expression. Okay, just notice that they're both the same. So this is going to be 2 over the square root of 5 over the square root of 6. Now, it's just like when you rationalize, okay? Numerators times numerators, and numerators times numerators, denominators times denominator. So the square root of 6 times the square root of 6, the radicals go away. This is simply 6. All right, now here we have to multiply the numbers times one another. Just to make sure you understand that. 2 radical 5 is the same thing as 2 times radical 5. So I can write the order here any way you like. I'm going to multiply the 2's together. So this is going to be 4. Okay, 2 times 2 is 4. And radical 5 times radical 5. The radical 5 goes away. So that's just simply 5. So we're left with 20 over 6. And of course that can reduce down to 10/3. All right. Okay, so we're going to be doing more practice with variable expressions and operations with radicals. But you have to get comfortable with working with radicals and simplifying them all over mathematics. And, you know, if you get a little lost, go back to the lesson and just take it step by step. All right, good luck.